Ajay Shah is a highly experienced food science technologist trained in the UK and holds impressive academic achievements and career highlights, both in Australia and abroad. He is an accredited auditor in cosmetics, good manufacturing practice, and corporate social responsibility in a number of certification bodies. Dr. Shah has lectured in the field of food science and technology to university students in Australia, UK, and New Zealand. In addition, he has reviewed food science and technology books for the Australian Institute of Food Science and Technology, as well as the Institute of Food Science Technology in UK. He has shared his expertise by presenting technical seminars at both local and international conferences. Dr. Shah has been operating a food technical consulting business for 19 years in providing scientific and technical food solutions to the food industry. He was recently awarded a Fellow of the Australian Institute of Food Safety and Technology in recognition of the outstanding service to the food industry in the fields of food science and technology.
Ajay, thank you so much for being here. As I wrote in the article, I had a really pleasure to work with you in this article. And I will start by asking you a bunch of questions related to the article. For instance, I would like to ask you first about if you can share with us examples of the food industries which would employ sieves to control foreign matter. Okay, and perhaps you can also talk about the various type of magnets that can be encountered in food industries in Australia.
Okay, yeah. Firstly, I'll give you a couple of examples. Firstly, thank you for the introduction. That was great. And thank you for the 3 people online right now attending the interview. Okay, firstly, sieves are utilized in a number of food industries. There is a couple of them that comes to mind from my experiences. I have a client working with fresh noodles. They manufacture fresh noodles, so they actually have sieves operating just at the point of when they have the intake of the flour into the silos. They have little sieves, so the flour is actually blown through the sieve, so no particulate matter actually goes into the silo. So that's one example. So basically, sieves utilized during uptake of flour from tankers into flour silos. The second example is in spice blending. So people who are actually blending spices, spices come from different parts of the world, and there is a lot of foreign matter there. So they actually have sieves to actually just make sure that they can capture all the foreign matter prior to blending the mixture. And then further down, they have magnets. Another example was in Tasmania, which is a great place for growing poppy seeds. Poppy is actually used in the for medical purposes. So this was a project for GSK, GlaxoSmithKline Beecham's. What they did was the capsules were used for the medical purpose. The byproduct was the poppy seeds. Now poppy seeds, have a lot of straw, a lot of foreign matter, soil, rocks. So they have sieves in the actual milling area, or where they actually clean the product, and they collect straws and things through what they have a tunnel. So the tunnel actually has screens. These tunnels are known as trommels. So they segregate stones, straws, etc. So these are 3 examples of sieves. In terms of the question about magnets, most of the magnets that I've cited are mainly rare earth magnets. Many particles, basically they can capture many particles, including metal and dust. Rare earth magnets can actually capture stainless steel and other sort of particulates of dust containing ferrous material. I've cited magnets in the feed meal industries, for example. So when the tanker comes and brings the grain, there is a gate where the tanker sort of drops the load of the grain into this hopper, and they actually have a rare earth magnet, which is a grid magnet. So it's a square or a round shape with the grids.
Mm-hmm.
You know, like if you can imagine three prongs, and that's a circle or a rectangle.
Yes.
So that's a very powerful magnet. It captures all the metal and other sort of soil and dust on there before it actually goes into the silo. The second example of rare earth magnets was actually uh, in mixing and blending areas as well, prior to anything going into the mixer or blender, because you don't want any machinery to actually um, cause damage through any metallic parts, you know, like say screws or nails or something. So it's important to capture that before it actually goes into the next phase.
Okay.
Another last
Okay.
example is the piping, you know, like pipes. Like if you're actually um, filling sachets of honey,
Mm-hmm.
and you don't want any of these material to come through. So they actually have what they call I've just got a name here. Sorry, they're known as magnetic filters, but they're all rare earth elements because the material is at very high pressure going through the pipe. You're talking
Uh-huh.
about 1,000 kilopascals, so it actually
Yeah.
captures that before it enters the machine where you actually fill it. So these are some of the examples of magnets that I've
Yeah.
encountered.
They are both for food safety, but sometimes also for protecting the machines. Yes, machinery.
Correct.
Yes.
Absolutely. Yeah. Yeah. So
Okay.
it's got dual function to protect the machinery as well as from a food safety perspective.
Sure.
But
And
further on
regarding,
downstream, sorry.
sure, continue, continue.
So further on downstream, you'll have to have a second measure, you know, like for example, a metal detector or something of that nature. But metal detectors want to capture small particulate amounts. They are very
Yes.
sensitive to a certain degree.
Yes, that was my question regarding metal detectors that are still widely used in the industry. There are anything novelty, any new metal detectors, any new technology that you would like, that you have seen recently and like to share?
Yeah, actually, this, as a matter of interest, this article, which is actually in the food and
Mm-hmm.
food and beverage, this is an Australian journal. This
Do you
came
have
in.
do you have it in PDF so I can share with everybody afterwards or not?
Yeah, I can try and give you a copy of the front page if they can download it. I think there is a website.
Mm-hmm.
Try and dig it out, and in there they have a section. Funny enough,
Okay,
that's the topic.
we can see. We
Uh,
can see.
you can see. So
Yeah,
it's
sure.
inspection systems protects brands, and there is a section that's a new metal detector that I'm going to be talking about. The CEIA has developed a multi-spectrum technology metal detector with cutting-edge technology, which is
Mm-hmm.
capable of eliminating false rejects without reducing sensitivity. So, yeah, this is the new machine. It's got um, what's the word? Basically, it's got multiple detection frequencies, so it delivers greatest sensitivities to all magnetic and non-magnetic metals, plus accurate compensation for product defect to reduce wastage, and also false reject signals. So, and it's self-calibrating. So that's a new one. That's the first in the world at the moment.
Yes, because that's still a big limitation of metal detectors, the false positives. Yes, and that problem that if the box is different or is filled in a different way, you can produce a positive, but it's not a metal. It's just the magnetic field that was changed. Yes.
That's right. Yeah.
Okay.
Basically, I mean, it's typically it's just a metal detector. It's just a metal box housing three transmitters, a receiver coil detector system, which transmits like a like a radio transmitter, and the transport coil generates an electromagnetic field. If the metallic object is present, it will interfere with the electromagnetic field, causing a signal to be detected by the receiver, and then basically, it just cuts off that signal. So there is a detection in the system. So yeah, basically, in a nutshell, that's the principle of metal detection.
Yes, and that's still widely used, but well, not perfect.
Not perfect. I mean, it's like when you see the price of metal detection, it's the higher the money you pay, the better the system you get. So the lower the sensitivity, and it's all about how much risk are you prepared to minimize.
Yes, sure, of course, yes. So Ajay, I noticed, I know that you last March that you attend to an AusPack expo in Melbourne. Perhaps you can tell us a little bit what you have seen there, any really new technology that you can share with the audience. What was really interesting for you in this? This is an exposition about packaging, yes?
Yes, it is. And what I saw was a couple of things. I saw a really nice. This is a UV tunnel. It's a German machine from Dinies, D-I-N-I-E-S. If anybody is interested, just go to that website. It's actually a UV tunnel.
Okay. Well, I will try, Ajay, but perhaps at least you can send us a photo. If you don't have it in PDF, you can send us a photo so I can send people after the interview, okay?
Yeah, sure. Okay. If you can just remind me to make a list of things. I mean, I know what I need to send you is this journal. And,
okay, I'll take notice. You can go on and present the AusPack, and I will take notice what I have to ask.
Sure. The other good thing about this thing is it's got the UV lamps, and you can actually this thing is actually for not wet products. Like usually you use UV tunnels in the beverage industry, but this is for the dry, for cereals, for spices, and also for dry fruits. So the application has changed to those sort of things. The other thing that I also came across was a really nice little package.
Yes.
This is a Swedish design called EcoClean. It's actually got a little handle which is inflated with air, and it's got a pouring pouch, so you can actually pour it. So you can actually now sort of this thing can be filled aseptically for UHT type products. So it's an eco-friendly packaging, so you can actually squash it down. I'll just show you.
Sure.
Okay, the same pack is when you finish the items, it just falls into that. So it's very easy to sort of dispose of rather than, cans and things. And it's actually got a little handle. Can you see that?
Yes, it's awesome.
Yeah.
Yes.
It's so if anybody wants to have a look at this, just go to the EcoLean website, and it's known as Snap Quick. So there's a little pouring spout here. So once you open this, you can actually, it's like a Ziploc, so you can actually fold it and clip it. So you can store this in the fridge once you've opened it as well. Very clever design.
Oh, very clever, yes.
Yeah.
Okay.
So that's
awesome.
One thing I saw at the expo. And then another machine was homogenizing under vacuum from Germany, which was quite interesting. But yeah, these are some of the things I saw at the expo here in Melbourne.
Okay, that's awesome, Ajay. So before I do my last question, that will be about your work and what about what you are doing, your plans for the future. I would like to ask you one question that perhaps you can share with us some advices, not only for people that are starting in food safety and starting as a professional in food safety area, but perhaps also in particularly if people are interested to work in Australia. You were sharing with me before the interview that this is a good opportunity, a good way, a good time for go to Australia to work on DOTS field. Perhaps you can share a general principle that you think is very important for food safety professionals, and perhaps also regarding your particularly in Australia, if you have any advice for us, for the rest of people.
Yeah, as everybody knows, Australia's products are regarded globally as clean products. So at the moment, we haven't had any nasty incidents like you hear everywhere else. So as a result of that, a lot of products are actually exported from here to China and also to United States, because products from here are regarded very, very highly. So because of that, our initial industry was basically just exporting raw materials. Now what we want to do is actually value add and then export. So this is creating more jobs for new people in the field. So there are opportunities. Obviously, the first call will be the local domestic market food technologists before they go looking for on an international circuit. So please don't run straight here. Just check out all these things. So there are opportunities working with the agricultural products, and there are governments, because the government is actually now injecting a lot of funding in innovation. So the universities are now working with industry on a collaborative basis to actually help each other in moving forward. So there are opportunities from R&D perspective as well.
Yes. Any particular advice for people in food safety and on the food technologies that are starting?
Oh yeah. Look, food safety is the biggest area globally, whether it's Australia or whether it's Europe. So that's always going to be the key. There are plenty of opportunities in quality assurance. So if you are starting afresh, just try and get more information on food safety. Try and attend training sessions if you can on auditing, etc., because there are opportunities as auditors. If you want to make a career in the auditing arena, that's quite interesting. But for me, for my expertise, I prefer to mix it. I like a little bit of consulting and a bit of auditing, because auditing can be a little bit more sort of mundane and dry. So, I like to mix it. So you have a variety. Like you say, variety is a spice of life. So in a nutshell, there are opportunities if you mix the two together.
Okay, awesome, Ajay. So before I ask about your work, I would like to remember everybody. I have here already a question from Hamed. So if you want, Clara or Claudia, if you want to make any questions, please, you can send me by using the chat. You can send me the question and I will do it, or even I will ask you to do it to Ajay. So Hamed, just 1 minute. I will ask Ajay to end the interview, that if he can share with us a little bit about what he has done, what are his plans for the future. Well, share with the audience what have you been doing and what will you do in the next years.
Okay. Very interesting question. How did I start? Okay, I was an academic, and once you're an academic, to break away into the real world of the food industry is very difficult. So somehow I managed to do that in Australia. That was it was a bit of a stranglehold. But the challenge was I never gave up, and once an opportunity came through, once you do a good job, automatically people recognize that, and it's more of word of mouth, and that's how I continued my business. So that's how I started my business. So I actually do most of my work in food safety arena. Quality assurance is big thing here in Australia. Product development, I do take part in that, but it's very limited. Most of the development happens between European countries and America. We tend to sort of modify things, whatever that happens over there. So yeah, it's mainly R&D and like product development, a little bit of R&D. I go to do a couple of lectures at universities when they invite me. Again, it's all paid. When you're a consultant, everything is, this is your income. So you have to sort of make sure that you get paid for all these things.
Of course.
I also examine masters and PhD theses from time to time, so I keep abreast with that. What else do I do? I'm very much involved because of my background in chemistry and biology. I broke away into the cosmetics sector, so I now do GMP cosmetics audit. So my advice is don't just limit yourself to just food area. You try and broaden the scope. So, if you run in one direction, there's a limited thing in that little pot. So it's always good to diversify yourself. And that's what I've done. So my consultancy business is a little bit more boutique in the sense that it's very diverse. It allows me to move in different directions. So when one area is sort of dropped down, I can move into another area and pick it up. And that's how I've actually worked my business over the past 19 years. So where is my next level of business going to take? I'm not really looking at expanding because it's a very boutique consultancy. So I'll just continue as I am for the next 5 to 10 years and then probably slow down.
Okay, then you come to Portugal to visit me for
Absolutely,
holiday.
I need to come there because I've got friends from Spain and Portugal asking me to come over. So yeah, definitely.
Sure. So we now thank you, Ajay, for your answers. I will now ask perhaps Ahmed send me a question. Ahmed, would you be interested to present the question to Ajay, because I read it, but I'm not sure that I understood totally what you meant. So perhaps you can turn on the mic and do the question.
Okay, thank you for your presentation, and I want to ask a question about the metal detector, and we need to verify or validate the metal detector, or just to ensure how to keep the accurate of the metal detector operation. Can you understand me?
Yeah, I think what you want is how do you validate and verify. Now, like you firstly, you have to sort of validate your metal detectors sort of, like basically just to make sure it's all in working order, at least once a year through the supplier, whoever supplied you with the metal detector. And in terms of the other thing, you have metal test species, non-ferrous, ferrous, and stainless steel. That should be supplied to you from the suppliers. Now, you need to test that depending on, every hour basically, when you're actually running the product. That depends. If it's a falling metal, like if there's a metal detector and the product actually falls through, then what you do is you check the product at the beginning and also towards the end, just to make sure that it's all working order. And if it's not working, then obviously that batch you keep it aside until the metal detector is fixed, and then pass the whole thing back again through the metal detector. Have I answered the question, Ahmed?
Yes, yes. You speak about we must validate the metal detector once yearly, and to verify the operation, we make it once each hour, or once start in the operation. To verify.
It's every hour, just to make sure that everything is working. And how to check the metal detector is that by putting test pieces. Sometimes what they do is they put test pieces within the product and pass it through the tunnel. Now the metal detector works in the way that if the tunnel, the aperture is small, it's greater sensitivity. So you have to put it under the product, over the product, and in the middle, just to make sure that the metal detector is able to detect the metal piece, the test piece.
Okay, okay. Thank you, thank you, thank you. I agree with you and I understand you with you. So, thank you.
Okay, thank you so much, Hamed. And well, Clara, if Claudia, if you want to make any question, please go forward. Just send me a message or just turn on the mic. Well, I would like to do. I will take this opportunity to do one or two questions more to Ajay. So we have some more time if you want to participate. Well, let's make this some more practical advices. You did a really you did a really interesting assistance and suggestion to Ahmed. But for instance, as we explained it in the article, sometimes people use sieves, and then they have to see if the sieves are broken or not. Okay. Do you have any suggestions? How do you usually suggest people to do that? What period of time? What is usual for you?
Okay, what we do here in Australia is, part of GFSI programs or even HACCP, for example, we actually have a system where we actually check the sieves prior, like a pre-check, a pre-operation check, and also after, once you've finished actually sieving everything for that batch, sometimes they actually open up the sieve just to clean it and just make sure it's all intact. If it's not intact, there's a problem. So you will probably either have a metal detector downstream that's able to pick up that sort of piece, or you can actually hold that product back and repass it again through the sieves, just to be sure.
Yes.
There are so many places which actually have a number of sieves. So in case the first one fails, the second one is in place, just to capture any fragments from the metal from the sieve.
That would allow an increasing the time for the verification. Yes, because well, how many from because you can do it every hour as you do in metal detectors to verify.
Yeah, no, sieves, it's very difficult to basically clean sieves because you can imagine, like a big silo of grain or whatever is going through. You have to wait until that's all done before you can actually go and sort of take the sieves out. It's like a wooden frame in like the older places, just to make sure that even that wooden frame of the sieve there's no wooden fragments coming off there. It's all intact as well. So there's a lot of things that when you're actually auditing, you just keep your eyes open and you learn a lot. The best way to learn is go through an experienced auditor. And you always learn new things from different auditors.
And perhaps my last question and related with this would be, because foreign matters, as we talk in the article, are really challenged for primary sector. Okay, so it's not easy to go to the field because the crops come with a lot of dirt, a lot of materials, and besides that, for instance, we also have that famous situation in Australia regarding the needles, and of course in the strawberries, and of course there is no metal detector in primary sector. People just don't use it because it will be always always popping up errors and alarms. So so as you said, in Australia there are a lot of primary sector. You are experienced with these products. Anything you would like to, any experience you'd like to share that you had? Anything that you saw that could be interesting for people to know if they work in primary sector? What are the best practice to control foreign matters?
I think now it's a very difficult to actually control foreign matter at that level, in the primary sector as such, unless you have some sort of powerful magnet, like if there is something going over a conveyor and it's got a sort of a plate magnet which can capture any metal. So if, like similar to rare earth, sort of at 11,000 gauss, which can actually shoot all the particle, like stone, rocks with ferrous material or nails or whatever, which is in the field, can sort of lodge onto the metal detector. That's one way I can think of. I haven't seen that, but I'm just
Yes,
visualizing
of
that.
course. It's mainly visual control. Yes, it's not.
It's mainly visual control at the moment, especially with the incident with strawberries. That was more of a threat. So
Yeah.
TACCP will be a big thing now, threat assessments. So all the companies are now, especially in Australia now, the TACCP is a big thing. So everybody wants to be trained in TACCP right now. And some of the companies who are actually doing training in this area are very busy. So how to actually make sure that you're actually minimizing that risk as well. The other thing is a lot of these fruit companies are now investing in putting metal detector systems in place as well. As you know, metal detectors are sensitive to moisture and also to natural salts, so that can spark off rejects as well. So again, as I said, the new metal detector CEIA, the one from that magazine, I hope that can actually do a part of the trick as well. So, you know, these companies need to test metal detectors in these sort of products like strawberries or raspberries or blueberries, anything of that nature.
So I think I will finish this interview. I thank you so much, first to Ajay, for the time. It's very early in the morning, if you not know, but this is 6 in the morning, 6 a.m. in Australia. So he took the effort to wake up early to be with us. So thank you, Ajay. It was really a great pleasure, and I'm sure that we'll work again on any articles or even to work in some problems that we can work together. I'm sure we'll do. And I would like to thank even more to Emmet, to Clara, to Claudia. I thank you so much for being here.